Good day. The topic we are treating today is geometric means. Before the commencement of this lesson, you must have been familiar with what a geometric progression is, how to obtain its common ratio, its first term, how to obtain the value of any term using the formula of its nth term, the relationship between its terms and its general form. The rules of indices and roots of numbers must have been known by you, so that by the end of this lesson, you will be able to find the geometric means of two numbers and a lot of other questions. Geometric means. If A, B and C are consecutive terms of a geometric progression, that is, they are terms that follow each other consecutively, then B, which is the middle term, is the geometric means of A and C. Assuming B is the nth term, A will be the n-1th term and C will be the n+1th term. So B, which is the nth term, will be the geometric mean of the n-1th term and the n+1th term. Then from the idea of finding the common ratio of a geometric progression, we know that if you want to find the common ratio of a geometric progression, you divide the nth term by the n-1th term, which is equal to dividing the n+1th term by the nth term, and that is what we have here. Then B over A is equal to C over B. So cross multiplying, you multiply B by B, we have B squared, and A multiplied by C, we have AC. So we have to make B the square root of formula here. We take the square root of both sides to eradicate this square. Taking the square root of this side, square, we eradicate square root, and we have plus or minus square root of AC. So the geometric mean of three consecutive terms of a geometric progression is equal to plus or minus square root of A, that is the first term, and C, and the third term. But we usually take the positive value. So let's take, for example, the geometric mean of 2 and 32. You know that we are looking for the geometric mean, that is B of 2, which is A, and 32, which is C. So we use this formula. B is equal to plus or minus square root of AC. Our A is 2 multiplied by C, 32. 2 multiplied by 32 will give 64. Square root of 64 is 8. And since we used to take the positive value, we take positive 8. That is why they said the geometric mean of 2 and 32 is 8. Then that particular GP we have is consecutive terms to be 2, which is the first, which is A, comma the geometric mean B, which is 8, and the last term, which is 32. So these numbers are three consecutive terms of a geometric progression, and 8 is the geometric mean. And the common ratio here is either dividing 8 by 2, which is 4, or you divide 32 by 8, which is also 4. So we move to examples. Insert three geometric means between 4/27 and 12. Here we have to insert three geometric means. The geometric means, we can represent them with letters U, V, and W. 4/27 will be the first term, and 12 will be the last term. So here we have a finite sequence. 2. State the geometric mean of 5 and 20. 5 here is A and 20 is C, and also 1.5 and 8/27. Here A is 1.5 and C is 8/27. 3. Three consecutive terms of a geometric progression are given as n-2, A, which is A, n, which is B, and n+3. So we have to find the common ratio of that particular geometric progression that has three consecutive terms to be n-2, n, and n+3. So this is a UTME past question, UTME 2003. So now we move to the solution of these examples. The first question says we should insert three geometric means between 4/27 and 12. So from the knowledge of the nth term of a geometric progression, if you are common with what a geometric progression is, you should know that the nth term, which is denoted as T subscript n, is equal to A, which is the first term, multiplied by R, common ratio raised to the power n-1, and n is the number of terms, and that is tagged as the first equation, where A is the first term, R is the common ratio, and n is the number of terms. So after inserting three geometric means between 4/27 and 12, we obtain the geometric progression 4/27, which will be the first term, the first geometric mean u, the second geometric mean v, the third geometric mean w, and the last term 12. So if we want to count the number of terms here, we know we have 1, 2, 3, 4, 5. T5 is the last term, and the value for the last term, and that is the value for T5, is 12. So this particular geometric progression is tagged as the second equation. So from the second equation here, there are 5 terms, and T5 is the last term, and the value for T5 is 12. So from 1, we know that T5, that is when your n is equals to 5, it will be equals to a r raised to the power 5 minus 1, and 5 minus 1 will give 4. So T5 is equals to ar raised to the power 4, and that is tagged as the third equation. From the question, the value for T5 is 12, and the value for T1, which is also the first term represented as a, is equals to 4/27. So since we have the value for T5 and a, we have to obtain the value for the common ratio r. So substituting these parameters into 3 to obtain r, we know that T5 is 12 equals to 4/27 multiplied by r raised to the power 4. So to eradicate this, because we want to make r the solid of formula, we multiply through by 27/4. So multiply this side by 27/4. That is, we have 12 multiplied by 27/4 equals to 4/27 multiplied by 27/4. That will give 1. 1 multiplied by r raised to the power 4 will give r raised to the power 4. So here, 4 here 1, 4 here 3. 3 multiplied by 27 will give 81 equals to r raised to the power 4. And we all know that if this is written in exponential form, we have 3 raised to the power 4 equals r raised to the power 4. So equating the powers, 4, 4, therefore r will be equals to 3. So we have r to be equals to 3. From the generalized form of a geometric progression, or from 1, we know that T2 will be equals to ar, because from 1, T2, that is when your n is equals to 2, is equals to ar raised to the power 2 minus 1, which is ar. T3, that is when n is equals to 3, will be equals to ar raised to the power 3 minus 1, which is ar squared, which is what we have here, which is equals to v, that is the second geometric mean. Then the fourth term, which is ar raised to the power 4 minus 1, which will give ar cubed, and that is the third geometric mean, which is given as w here. So we substitute the value for the first term and common ratio, we multiply them together to get u. We substitute the value for the first time and we multiply the common ratio twice with the first term, we get the value for v, and we also get the value for w by multiplying the first term together with multiplying the common ratio thrice. So now substitute the parameters into this. We have T2 to be equals to 4/27, which is the value for a, multiplied by 3, which is the value for r. 3 here 1, 3 here 9. 4 multiplied by 1 will give 4. 9 multiplied by 1 will give 9, which is the value for u, that is the first geometric mean. T3, the second geometric mean, will be 4/27 multiplied by your common ratio raised to the power of 2. 3 raised to the power 2 is 9. 9 here 1, 9 here 3. So that is why we have 4/3, which is the second geometric mean. And the third geometric mean, which is the fourth term in their geometric progression, is equals to 4/27 multiplied by 3 raised to the power of 3. And 3 raised to the power 3 is 3 multiplied by 3 multiplied by 3. 3 multiplied by 3 will give 9. 9 multiplied by 3 will give 27. So 27 will cancel 27, and that is where we have 4 to be the value of w. Therefore, the three geometric means between 4/27 and 12 are u, which is 4/9, v 4/3, and w 4. And this forms the geometric progression. The first term is 4/27. The second term, which is the first geometric mean denoted as T2 or u, is 4/9. The third term, T3, is 4/3. The fourth term, T4, is 4. And the last term, which is the value for the T5, is 12. So this forms a geometric mean. This forms a geometric mean with common ratio 3. So now we move to the second question. Here we are asked to find the geometric mean of two numbers. The first one is 5 and 20, and the second one is 1.5 and 8/27. So now, since B is the geometric mean between A and C, from the previous slides, we are given that the formula for finding the geometric mean between two numbers is B, which is the geometric mean, equals to plus or minus square root of the first number multiplied by the third number, and we usually take the positive value. So we'll use this to answer the questions. The first question, A is equals to 5 and C equals 20. So you know from the formula, B equals to plus or minus square root of A multiplied by C. So A is 5 and C is 20. 5 multiplied by 20 is the same thing as writing 20 multiplied by 5. So 20 multiplied by 5 will give 100. So B is equals to plus or minus square root of 100. And you know 100 can be written as 10 squared. So square will cancel square root, or you know the square root of 100 is 10. So B is equals to plus or minus 10. So since the positive value is always taken, then the geometric mean between 5 and 20 will be positive 10, which can be written as ordinary 10. The second question, we know that from the second question, A is equals to 1.5 and C equals to 8/27. So B, from the formula, B equals to plus or minus square root of AC to be plus or minus square root of 1.5 multiplied by 8/27. You know, if we change 1.5 to improper fraction, it's the same thing as writing 3/2 multiplied by 8/27. 3 here 1, 3 here 9. 2 here 1, 2 here 4. 1 multiplied by 4 we give 4. 1 multiplied by 9 we give 9. So B is equals to plus or minus square root of 4/9. Also, since we know from the rule of indices that square root of A over B is the same thing as writing square root of A divided by square root of B. So from here, square root of 4/9 is the same thing as writing square root of 4 divided by square root of 9. And we all know that the square root of 4 is 2 and square root of 9 is 3. Therefore, B is equals to plus or minus 2/3. Since the positive value is always taken, then the geometric mean between 1.5 and 8/27 is 2/3. That is, we ignore the negative 2/3 and we take the positive 2/3. So now we move to the third question. We all know that we are asked to find the common ratio of a geometric progression that has 3 consecutive terms to be n-2, n, and n+3. And from the idea of geometric mean, we all know that B, which is the second number which is second term in those 3 consecutive terms, is equals to plus or minus square root of the first term multiplied by the third term. So from the question, A, which is the first number, is equals to n-2, B equals n, and C equals n+3. So we substitute all these parameters into the formula B equals plus or minus square root of AC. This implies that B, the value for B is n, equals to plus or minus square root of A, n-2 multiplied by C, n+3. Taking squares of both sides, that is, if we want to eradicate this square root, we take squares of both sides. We have n multiplied by n will be n squared equals to square, you cancel square root. We now have n-2 here multiplied by n+3. So we open this bracket. We have n squared equals to n multiplied by n we give n squared, n multiplied by positive 3 we give positive 3n, negative 2 multiplied by n we give negative 2n, minus negative 2 multiplied by positive 3 we give minus 6. So we have n squared, positive 3n, we subtract negative 2n from positive 3n, we have positive n minus 6. So now we collect like terms. We first move this to this side. We have n squared minus n squared equals to n minus 6. N squared minus n squared will give 0. So we have n minus 6 to be equals to 0. So we move 6 to this side. We have n equals to 0 plus 6. Therefore, we have n to be equals to 6. So substitute n equals to 6 into the consecutive terms of that particular GP to give, the first term is n minus 2, so 6 minus 2 will give 4. The second term, which is the geometric mean, b, is n, that is 6, and the third term, c, is n plus 3, and 6 plus 3 will give 9. So to find the common ratio of a geometric progression, that is r, is like dividing the nth term here, the second term, the middle term here, by the first term, which is 6 divided by 4, or which is also equals to dividing the third term, 9, by the second term, 9 divided by 6. So if we have to take this to its simplest form, 3 here 2, 2 here 3, 2 here 2, we give 3 over 2, 3 here 3, 3 here 2, we give 3 over 2. Therefore, the common ratio is r. The common ratio of a geometric progression that has 3 consecutive terms to be n minus 2, n, and n plus 3 equals 3 over 2. So these are exercises to work to see if you really understand what we have been discussing. Next video will be on some of arithmetic progressions with sample questions and solution. Please subscribe to our YouTube channel, like and share our video. Thank you.